Hello, this is Stefan Koch, and today we are going to fix default arguments. And this is gonna be great. Yeah. Now, shall we? Okay. So, what do we want to do but default arguments? Well, default arguments are arguments, trailing arguments that are written for you into the call. They're just like regular arguments, just that you don't have to write them. So, after we get the arguments to our function, what we need to do is to walk through the parameter count, and for every parameter which we don't have an argument for, which means if our argument count is less than our parameter count, we need to put in a default argument. Now, in DMD, the default arguments are parts of the parameter types. So we need to walk through the function type dot parameters dot default argument is going to give us what we need. Maybe we just give ourselves easy access to that. Default args would be a type function dot parameters. Problem is, here's the I and then comes the default arg, right? So we need to use die here. Default argument index. So as what should we start? Well, we start with however many parameters we have, right? We go from our ce.dim ce.arguments.dim until we hit our end parameters, and the default of for each, which will not go at all if the beginning is greater than the end, is exactly what we want here. So this is the default argument index, right? The default arg we want to put is this one. So all we need to do no, I don't want to purchase Sublime. All we need to do is to put this into our array of BC arguments. Now, this array is gonna be too small, right? Why? Because we haven't taken it into account when we did the length of it. So we'll just compute the length. Last arg index is the maximum of ce dot arguments dot dim comma and parameters. Hope that we have this here already. Do we? Yeah, there it is. So Either we have enough arguments or we have more parameters than we have arguments. So the last index will be this one, right? Question, well, do we want to count at this point? I think so. Right? And then we set the length. Nah. We do this. We take this, right? And we set the length to the last arc index. Plus this pointer, right? And then we can, if we have this pointer, take last arc index here, right? This should work just fine, right? Now we go from the arguments to the parameters, and we will only get here if we have default arguments. So what we do then is to put in btargs of default argument index equals general expression of the default argument. And that should be it. So if we did everything correctly, we can now build. This should build. I just don't know what wrong. We don't have maximum. Huh. Oh well, then we just do the old-fashioned way of maximum. Which is fc.args arguments. The dimension is bigger than n parameters. Choose args arguments dot dimension. Otherwise, choose n parameters. Yeah. Yeah, and we don't have support for the other case. Yeah, of course we have to cast this to you and I do not expect us to have more than 4 billion arguments. They wouldn't ever fit on the stack. Probably man parameters. Wait, where? 5371. Parameters. There we go. Whoops, no default arc. I go type function parameters. Wasn't this exactly what I just killed? Pretty sure it was there. You see this too, right? And the function type dot parameters. So I really don't see why I can't get at the default arc. Well, TF parameters. Oh, yeah, right. There's a pointer to an array, and if we don't put the braces, we will slice the pointer instead of indexing the array. Yeah, that's the problem. Happens all the time. Because you usually don't find that stuff in regular decode. Right. Misplaced parentheses. Now it compiles. But does it wrong? I always forget that. There is no POSIX mark for this. So let's just watch if there is something failing or not. Yep, something fails. And you probably can't see this, but this test failing means that the default parameters are not used. Tricky. This is tricky indeed. This is very tricky indeed. Okay, let's make a test, I guess. So all we need to do is to remove this constructor. And to add the default arguments back in here. Then make sure we use the freshly built DB. Alright. I think it was CTFE test. And now this runs. But we need to make sure that it runs correctly. So the default arguments seem to be used here. Let's have a look at what is actually going on. Using our handy debug switches. I like to have backup messages, results. Yeah, that's it. And let me make this a bit bigger so I can read this. So it looks to me as if this works the way it should. So let's inspect the failing test. And let's inspect the IR for the test I just ran. Whoops. I've got to debug this later. So the test we ran was iota. Actually the constructor for iota. This all seems reasonable. Just don't know why it has 67 functions. Wow, array equals as large. And stir cut doesn't do anything at all. So let's see what GDB says. a dice at begin function. This suggests a null pointer, and the printer generator tries to print the function. Tries to print a function which has no name. They should be easily fixable. Let me check. There should be in source DMD CTFE BC printer backend and begin function. There. Yeah, right. This works only if we get something back from a FD2 chars. Otherwise, the string is empty. It has no name, right? Nameless. Shouldn't it be FD ident? Well, whatever. We ask for FD ident. If we have one, we make the function declaration to string. If we have none, it remains nameless. And now we should be able to execute this. What? Do I have to put braces here? Seems like it. Now we should get a seg fault. And we still get one. Where exactly? Must have something to do with passing in a null as function. Yeah, I think I already know what it is, but I wanted it. Yes. Yes. The thing is, we can have functions which we generated ourselves. And when we generate them ourselves, they don't have a function declaration. Meaning, this will only work if we actually have an FD. Right? We're trying to get the FD ident here, but that only works if we have an FD. If we have none, then it doesn't work, because there is a null, right? I guess I could do this. like that. This make sure that we don't pay for the dynamic check. We shouldn't do anyway because this is an external C++ function, but can't mess things up more than they already are messed up. With which assertion failure hits us here? Something in 242. Oh crap. This means we have a problem. How come the interpreter can do this? Wrong. Fine. Let's enable the interpreter again. And suddenly it can't. What? Inside the code generator it fails. Is it because I built the debug build? Or is it that the ABI looks different between debug and release builds, and we can't mix them because since the make files have been changed, the recompilation doesn't work the way it used to. We can now see how a giant recursive function is being executed. Well, probably shouldn't have run this under GDB. Well, let's wait till this is finished. Nah, this is going to take forever to finish. So let's just do this. Whoops, not with the GDB. When it doesn't have to print out to the console, it may be faster. So this time I ran through. Should have printed a recursive function trace. That's a lot of lines, right? It's because one function in here executes a factorial of 6 times. And I forget to terminate a string here or do something else with a memory that's funky. But that's this only for the debug printout, so who cares? There you can see here the stack offset of the stack pointer growing and growing. This means that we are inside recursive function. See, grows and grows and grows. Horrible, horrible stuff. Anyway, so this seems to work now. Let's see if we can get the bytecode. Here. First we clean, then we build this again. Just to make sure that we don't have ABI issues just like 10 minutes ago. Did I use LVM backend? Oh yeah. Enable the wrong backend. We want the printing backend. Then we can see if the default parameters are added or not. And they are, you can see them here. Here the function, and then the two default parameters here. Now, to confirm that this is what happened, we can comment out the default parameter handling, and then we should still have the same output here for IOTA. Wrong. When we comment out the default parameter handling, then the output for IOTA will only be this. It won't have those two. Right? If I do this, there. We should be missing them. But they're still there. Which indicates that we do something wrong here. So function 4 is the constructor. It's the one we should call an iota. But in fact we call function 5 here with a 0 and the 1. Oh yeah, right. Function 5 is the constructor. So that's alright. So where do the default arguments come from if not from there? Well, it's not this constructor, we remove this constructor. So the default arguments seem to be get put in there for us when we do the call. So this means we didn't fix the problem at all. Alright, my voice is leaving me, so I will load this up and see you next time.